maybe you can get an idea from that. So I've rigged up these lines here to go over a WebSocket to Node serial port into the machine, or into gerbil on the machine. And so I can, there we go. Okay, so this is the homing sequence. Gerbil accepts the command $H. And so it will run to the homing switches, and that way you can index off of the same position every time. This command is really awesome. It sets up your working coordinates. So machine coordinates are all in negative, and they're kind of hard to deal with. But you can set up machine coordinates wherever you want. Then we can actually move the thing. Move the Z down. Go back to 0. And there is an RC helicopter motor on there, rigged up with some bearings and a cullet, so I can actually turn that on, hopefully. Yeah. It's not dangerous at all, I swear.
Eli, should we all come up now?
Oh yeah, almost ready, almost ready.
Does it fly?
No, no. Sounds like it though. I call it the crybaby, because that's not really as fast as we can go. That's like a third. So it starts to scream. Okay, so those are kind of the easy parts. This was not necessarily easy to build, but relatively, those are the easy parts. The difficult parts are computer-aided design and computer-aided manufacture, which we'll go over now. So a good CAD package, software, whatever you want to call it, does parametric modeling. So you're doing Boolean operations on 3D features, and basically your shapes that you're creating are based on all of these combination of all of these operations. It has good dimensioning, so you can actually just take like a virtual ruler or dimensioning guide and just say from here to here, this feature to this feature, this extruded cut over here to this thing, and it will tell you exactly how, exactly what that distance is. And it should be easy to navigate, like ideally, all of these things. And so SolidWorks, which is thousands and thousands of dollars, does these things. It does them extremely well. But like I said, it's tons of money. It's not open. You can't hack on it. There are issues, there are usability problems for certain types of modeling that you might want to do. But it's like the king of parametric modelers to date. You also have Tinkercad, which is another parametric modeler, but it doesn't have the greatest dimensioning. And I guess it's more suited towards beginners and like 3D printing and, I don't know, kids, maybe? I don't know.
What's it called?
Tinkercad. Yeah. And then we have Blender. So when you do parametric modeling in either Tinkercad or SolidWorks, you don't have to worry about your verts or making sure that your model is watertight or manifold. You can just kind of perform these Boolean operations on the solid features, and it handles the rest for you. It generates geometry and the triangles and the quads and all that stuff. When you work with Blender, you can do pretty much the same stuff, but there's a lot more geometric, like 3D model. How do you explain this? You have to generate the triangles yourself. It's not automatic for you. And so it becomes a bigger hassle because every time you want to change a feature, you have to rework and optimize your meshes. So those are our options in the desktop world for CAD. For CAM, CAM is basically, who knows what CAM is? Okay, a couple of people. So CAM is, like it says, toolpath generation. But essentially what that means is there are different ways to perform operations on a CNC machine against a workpiece. So in this case, this is a CNC router or mill or whatever you want to call it. So it's going to remove material. So if I created a cube and I had a big piece of stock, and I wanted to cut the cube out of that piece of stock, the toolpath generator would actually figure out how to efficiently go through and make the cuts on the machine without me really having to tell it what to do. And there are various levels of these as well. So there's HSMWorks for SolidWorks, which is more money, tons and tons and tons and tons more money. Like you could probably spend $20,000 in this space, easy. There's Mastercam, which also has a plugin for SolidWorks. So everything like plugs into the SolidWorks package. This is actually, I believe it's a mold. It's a toolpath for a mold, so the cutter is going to follow those lines. It's kind of interesting to think about like most molds today are actually made using a CNC. So there's a lot of things that are actually touch like a CNC'd surface or are CNC'd themselves, which I don't know, it's kind of cool. I think it's important that we have more control over that. Here's something called MeshCam, and it does not do as great of a job as the previous two. You can see by all the red lines, it likes to kind of jump back and forth, and I don't know. But it's not as expensive. It's only $250, so it's on the low end. And you have CamBam, which is kind of difficult to use. And I haven't actually used this, but it seems to work pretty well from what I've seen. So using SolidWorks and HSM Express, which is a trial version, a free trial of HSMWorks, I can generate a toolpath to cut out the JS logo. Now, I know this would be more awesome if it was done in JavaScript, but it is extremely, the features of the JS logo are actually kind of tricky to pull out and actually offset and perform these toolpath generation operations on. So who wants to see me cut this thing out? Yeah? Okay. This might fly off, so guard your eyes. It's going to cry about this guy. So it homes, and then it starts running a bunch of G-code. So this takes a little bit of time. So I wanted to do two things while this was happening, if it's not too loud. No? What's that? Okay. It's kind of loud up here. Okay, so basically when I was building this, I modeled it in SolidWorks for, I don't know, 2 weeks, off and on. And the goal was to make it fit in a carry-on that would travel in like the airline with the smallest baggage requirement, right? So that I could, no matter where I went, it would fit and they would take it. So that took a bit of like thinking and engineering, and that's why it folds up, and when it does, there's magnets that kind of catch it and hold it into place. All of this took 2 weeks, right, to design. And then I went to cut out all the parts on the CNC, on the big CNC, and that took about a solid, literally a solid week, 24/7, my neighbors hate me, of machining all the little parts that are on this thing. I didn't get much sleep. I don't even know what sleep is anymore, honestly. Okay, that's sort of working. I don't know. Does anybody have any questions? Oh. Oh no. Oh, I broke it. That's right. Yeah, they didn't do anything. Yeah, it's like a big box of metal that beeps when you turn it on. Like, there was no body scanner or anything. Like, I would have opted out and then, had to deal with, them checking and swabbing this.
4 ounces of shampoo.
I did have to take off my shoes, yeah. But yeah, it was really amazing. I just walked through. There was nothing. So now they're probably going to watch this. Check it next time. I don't know if I should complete this cut or not. Like, it takes a little while. It takes like 7 minutes. I don't know how much time I've been up here already. Okay, let's just move forward for now. If you want to see it, I'll have it at the hardware workshop, and you can see it in person if you go like this while it's going. Okay, so I want to build open source software that replaces this big bloated proprietary crap, right? Like I want all of us to be able to hack on tools that we can use against like 3D printers and CNC machines and like big commercial like CNCs, if anybody has access to those. Like I want us to be able to write the tools and hack on them to be able to do what we need to do. So here's 2 projects that kind of do some sort of CAD things. CSG is parametric, or it's kind of like a parametric CAD in that you can write code, like create cube, and then Boolean, like a cylinder through it, and the resulting object you can export to STL, and you could print it. There's this thing called laser beam, and basically what it does is you draw half of a lathe shape, and it will basically create the full lathe 3D object. I don't know if that makes sense. That you can 3D print right after that. So I'm sure there's more, but there's nothing full-featured as far as a parametric CAD goes, and I think it's really important that somebody does it. I'll probably be working on that next. So I've been working in the CAM space because I'm really interested in, like my holy grail, or my white whale rather, is to cut out the JS logo by code that's generated from JavaScript, and not just like hand-coded, like, okay, now go over here and then go over here. Like I want it to read the model, and I want it to decipher how and process and figure out how to actually get into those features and like actually cut the parts out that it needs to cut. And so my first attempt at this was SVG, because the JS logo comes in SVG. It's SVG mill. And Dominic Tarr just raised an issue on this a couple days ago, and he's like, why doesn't this work? And I have a good reason why this doesn't work. So there's a bigger problem than just converting SVG into toolpaths. Like you could just say, just follow the path. But the problem there is you actually, the width of the tool, if you just followed the path, you'd be undercutting half of your shape. So that makes problems when you're actually, I don't know, you want to be dimensionally accurate. So the other project that I'm working on is poly offset. And basically what this does is offset a polygon. And so basically you want to offset the polygon by the tool's radius. That way you can cut completely on the inside of the path or completely on the outside. And you could actually do some really basic like clearing techniques by just offsetting and offsetting and offsetting until there's nothing left to cut. And then you could just repeat that on the z-axis and cut deeper on those lines. So an example of this is kind of where I am right now. The blue circle represents a cutter, and as it goes around, I'm simulating it getting bigger. And as it gets bigger, there's these little ears on the polygon that's being offset inside. They're appearing, and I'm pruning them off. So the green is what's actually being cut, or that's actually the path of the the tool bed. So this needs some work, but there's a lot of research papers on this, and I will get it. It's just a matter of time. It gets faster and faster. Then it explodes. Come on. Okay. Yep. So, big CNC is up there in the upper left, and I'm sleeping with my dirty hands and safety glasses. Yeah, I figured if something bad happened, it would be really loud, and I'd be right there. It would wake me right up. That's it. Thanks, guys.